Hey, it's Emma here. Let's get started learning about communication basics. For this topic, we've basically got to learn 5 core definitions, and while it might seem like a bit of a chore, they are really important. Our first term is baud rate, which is the rate at which signals can change state per second. Its unit is the baud, shortened to BD. The baud rate is one term that can be used to describe the speed of transmission. If a port has a baud rate of only 1, the signal can only change once a second. The actual change occurs at the end of this elapsed second. Note, although mentioned here, it needs to be included with the definition. In comparison, a baud rate of 2 means you can have 2 signal changes per second, so a gap of half a second between voltage changes. The more voltage changes per second you can make, the more data can be transmitted. This is why the baud rate is a measure of the speed of transmission. The greater the baud rate, the faster you get your data sent. For signals with only 2 possible states, 1 baud is equal to 1 bit per second. However, the main way to describe the speed of transmission is the bit rate. This is the number of bits transmitted per second, with the base unit being bits per second, or BPS. So both the baud rate and the bit rate can be a measure of data transfer speed, and they can be the same. If we use only 2 voltage levels, one representing binary 1 and one representing binary 0, then the baud and bit rate are the same. This is because each signal, represented by a grey box here, only represents 1 bit, either 1 or 0, so the number of changes per second equals the number of bits transmitted. We can now, however, switch it up so that they are different by increasing the number of bits each signal can encode. Instead of 2 voltage level on the previous slide, we now have 4 at our disposal. This means each different level can be used to represent a different bit pattern. It means that despite the baud rate still being 1, we are now transmitting 2 bits per second. If we wanted to have a bit rate of 3 bits per second, with our baud rate being 1 still, we would need 8 distinct voltage levels because 2 to the power of 3 is 8. This is the equation that links the bit and baud rate. If you understand this, then you've understood what I've just talked about. Now moving on to our third definition. In a communications context, bandwidth refers to the range of the signal frequencies the transmission medium can carry. By medium, we mean like the air or wire. The unit is the standard unit for frequency, hertz. The higher the bandwidth, the greater the amount of data that can be transmitted in a fixed amount of time. You can think of bandwidth as being like the width of a pipe or a tap. The larger the width, the more water can flow per second, which is this analogy's equivalent to the bit rate. Therefore, as the bandwidth increases, so does the bit rate. For a good representation of the data, you need the bandwidth to be roughly twice the value of the bit rate. Formally, bit rate is directly proportionate to bandwidth. Our penultimate definition is latency, which is a general term for the delay between something being initiated and its effect. In a gaming context, this is called lag. Latency can really occur at any part of the transmission process, but transmission latency is specifically the time it takes to pass through the transmission medium. Fiber optic cables would have a lower latency than normal metal ones, for example. Like latency, the final definition is another you'll use a lot, So get comfortable with it now. A protocol is just a set of rules that communicating devices need to follow in order to exchange data. We'll look at major examples like TCP/IP and HTTP in the future, but protocols are needed in general in order to set conventions. Otherwise, every device would try to communicate in a slightly different way. Okay, so let's recap and leave you with the definitions. Pause and reread these to ensure you understand them. Remember that the bit and baud rate become different when you start representing more values with a single signal, and that increased bandwidth results in a higher bit rate because they're directly proportional.